Dice rolling is a fundamental part of many games, and in multiplayer games it's critical that all players see the same rolls. Now I'm working on porting over one of my favorite tabletop games to the PC, and it features a lot of die rolls, so I had to build a system that could make sure that the server picked a random number, but still gave the players a feel of rolling the dice. Now there are a ton of Unity dice roll tutorials out there, and I went ahead and watched them all for you and combined that with the design I did for my game to make this simplified dice roller that is network synchronized using Unity's Netcode for GameObjects, and this tutorial will take you through how to get that set up for your game. Let me explain what we are going to build here first. We're going to go through and build a simple network dice roller that will allow 2 players to log in, select to roll the dice, and then just keep a running total of what each player has rolled. We're going to build it server authoritative and use physics to determine the dice rolls. Now in my game that I mentioned earlier, I'm actually using a deterministic approach instead of a physics approach. So let me explain why we're not doing that here. I started off playing and writing games back in the dark ages of dial-up connections and modems. And then my first job out of college was as a network engineer. So I am hardwired and morally opposed to putting any traffic on the network I don't have to. So when I started working on my game, I only wanted to send a single integer value across the wire for die rolls and let the clients then generate an animation that worked. Basically, I just faked the physics on the clients to make the die roll what I wanted it to roll, and this had the benefit of doing very little network traffic, but does mean the players are actually seeing different things, and occasionally it's noticeable when the physics has to hide something. When I started making this video, I was going to show it both ways, but after I built it using the physics way, using Unity's network transform, I realized it's actually way more efficient than I thought, and for most cases this is probably how you should do it. It makes all the players see the same thing, it doesn't have the potential glitches that my other approach did, and the network impact is actually pretty negligible at around 4 kilobytes to 6 kilobytes of data for a die roll. Now this video is not going to be an in-depth tutorial on netcode, but I will cover the absolute basics to get you started. If you're interested in a more in-depth tutorial on that, certainly let me know in the comments and we'll see what we can do. Okay, so let's get into it. First thing, for this tutorial I'm using Unity 2023.2, but any 2022 version should work just fine. I'm using the 2023 version because I want to use the multiplayer play mode package that's not available for 2022. You really don't need to have it, it just makes testing during development a whole lot easier, and it's just a tool that I like to use. So once you get Unity installed, there's 4 packages we want to add. Netcode for GameObjects, this is the base networking module that we're going to use. The multiplayer tools, technically you don't actually need this one for what we're doing, but it does have some nice debugging tools, so you might want to check it out. The main one that I care about right now is NetStats, which gives us some performance measures on what kind of data we're sending across. Multiplayer play mode. Now this is actually an experimental package still, so you have to add it by URL, which I'll put there on the screen. This is a nice package that actually lets you open up multiple different Unity instances to run each of your network players. And quite frankly, this is the whole reason why we're using 2023.2. If you're using 2022 or just don't want to use an experimental package for whatever reason, it just means you'll have to do either frequent builds to test out the networking or use some of the other third-party tools that are out there that have a similar experience. Personally, I think it's just easier to use this particular package. And then the last thing we're going to do is, since this is a dice roller, I went ahead and grabbed this free dice asset to use for the actual dice in the game. Awesome. All right, so let's get going. Since we want this set up kind of like we would do with a real multiplayer game, we're actually going to make 2 scenes, one for connecting to the game and one for actually rolling the dice. Let's set up that first scene real quick. Since this isn't, like I said, a full networking guide, we're going to go through this a little bit quick. In this scene, we need 3 basic things. A canvas to let the player pick if they are the host or the client, a prefab for the player, and then the network manager. In the interest of time, I've actually already made the canvas here. It's just a simple canvas with 2 buttons on it, one to start as a host and one to start as a client. And then a simple UI controller script that either just starts the host or starts the client, depending on which button they press, and then loads the game scene once the server itself is actually ready. Now we also need a game object to hold our network manager, and then on that network manager, of course, we have to set the transport protocol we're going to use, and then in the spot here for the player prefab, we're going to go ahead and create one. So we need a player prefab, which right now is actually just going to be an empty game object with a network object component on it, and we'll build that out later as we go. And really, that's everything we need for our basic network setup. Obviously, if this is a real game, you'd have authentication and a lobby and, you know, all those kind of different things. But for our purposes today, this will do just fine. Now, in our main game scene, the first thing we're going to do is create a surface for rolling the dice. Of course, this should actually be your game board itself, or like a craps table or something like that if you're doing some type of casino game. But for this game, we're just going to make a simple box and position a camera pointed at it. This is actually what I did in my game, as you may recall. But what I did is I have a secondary camera pointed at the box, and then I only render that camera onto the screen when the player is actually rolling. I made this with a simple plane for the floor and then some cubes for the sides. You will want to make sure that you have the colliders turned on, and you can see here in my design I actually extended those colliders much higher than the box visuals just to make sure the dice never escape. Of course, you should set up however that makes the most sense for your game. Now that we have our box, let's set up the dice. I decided for this tutorial I wanted to have two different dice colors for the two players, so I'm actually using both the red and the blue prefabs from that dice package we downloaded. But since these are just models, we're going to have to add some additional components to them to get our prefab. You will need to add a rigid body so that we can apply physics, and a network object so we can spawn the die on the network, and then a network transform so that Netcode can handle keeping the die's position and rotation in sync with all the clients. Now, I also changed the scale on mine to be twice as big just because it looked better with the box that I made, but of course you can set the scaling however makes sense for you. Two more things we need to do in order to figure out which side is up when the die finishes rolling. We're going to attach a script, and for right now the only thing we need to put in this script is an array of transforms to hold all the die sides. And then we're going to make 6 empty game objects, one on each side, and put them in the array. Now you just need to put these on each side, and the orientation doesn't really matter, but when you put them on the array, we want to make sure we do that in number order. Later on, what we're going to do is we're going to test the Y value of these transforms in order to know which side is on top. While I do that, I should point out there are lots of ways to figure out which side is facing up. You can do dot products on the sides. You can fire raycasts from the die. You can put colliders on the die and then pick the opposite collider from what's on, and so on and so forth. There's a lot of different options, but I think honestly for a 6-sided die, this method is actually the easiest method to go with. Okay, and then we want to save all of that off as a brand new prefab. Like I said, I did this twice so that I could have a separate prefab for each player. Let's build out the rest of our dice script now. First, we're going to have a simple struct to be able to pass back the data about ourselves to the rest of the game via an event, and a main function in this script called rolled dice. For this, I'm just using a basic Unity event, but of course in a real game you probably build out your own event handler and a full event system, but that's obviously beyond the scope of this particular video, so this will be sufficient for what we're doing today. Basically what our roll dice function is going to do is going to take input from the controller for which player we are for, some force multipliers, and then add in a bit of random torque and push ourselves off. Now, there is this ready to check result field. This is to make sure that we wait just a touch before we start testing to see if the dice has stopped, since technically we'll actually start off stopped and we don't want to try to grab that initial result. So we're just going to put a little 1-second delay here with this async call before we start checking for the die results. On updates, we're going to check to see if that value's been set yet, see if our second has gone by or not, and then start checking the angular velocity to see if the die has stopped spinning yet. And if so, then we're going to try to actually calculate the value. Calculating the value, like I said, is pretty easy with how we've set everything up. We're just going to go through and we're going to loop through each of our side transforms and see which one has the highest value. Then we just add that into our data struct and fire off that event to let the game know that we've stopped rolling and what our values are. Okay, let's get set up so we can try this out. We simply need to get a canvas and a single roll button to roll the die, and then we'll need 2 controllers, one for the GUI and one for the roll controller itself. Let's handle the roll controller first. What we're going to do here is set up a couple of parameters, use as force multipliers, so that you can experiment and get the desired results you want for your die, as well as have references for our prefabs, so we'll know where to spawn the dice and which dice to spawn. We need one main function here for the player to be able to send in a request to the server to roll the dice. Now, if you're not familiar with this setup, this is called a server remote procedure call, which is exactly what it sounds like, a remote call for the server to do something. Any function used like this in Netcode must end with the name server RPC, as well as it does have to have this command flag on it. In this case, you can see that I put the require ownership flag as false because really we're going to let any player call this function, and it doesn't need to be, just the one that's owned by them. It's going to take in 2 values, an integer for the number of devices to roll, and then a set of server RPC parameters. Now netcode will let you create your own, but this one we really actually only need the default, because the only thing that we care about is knowing which player is requesting the role. So the default will work fine, and we're not going to make any changes to those parameters. Plus the nice thing here is now using the default, our calling function actually doesn't need to know anything about the network behavior at all. All right, so the first thing this function is going to do is get the information about the player making the call so that we can pick the correct spawn points and prefabs. Now, I wouldn't suggest you actually hard code your client IDs like this, but since we're just limiting this to a simple 2-player demo and getting into player management is way beyond the scope of this video, this is going to work for us for right now. Now we're going to go ahead and instantiate the prefab, spawn it onto the network, and call its roll die function that we set up earlier. And the UI controller, all we need to do is add our button to call the function, and then we need to set up our references in the inspector. Okay, let's try this out before we add anything else. We'll need to save everything and switch back to the scene that we created originally for our networking. If you are using 2023.2, now you can go ahead and open up the multiplayer tool and tell it to activate player 2. I should point out a couple of times I have seen this experimental package glitch out a little bit, and if that happens to you, all you need to do is close the second player and reopen it, and that usually solves the problem. All right, now that that's running, I can click the button, and sure enough, the die is rolled. And that's all great and all, but let's go ahead and get it set up to know what was rolled and associate it with the correct player. One thing I should point out here, when I'm doing a multiplayer game, one of the things that I like to do is set up a simple script to always open up that networking scene first, so I don't have to remember to switch back and forth to it. All you have to do is make a simple editor script, which you put in your editor folder, which tells it to always open whatever is defined as scene 0 whenever you enter play mode. Okay, back to the game scene. There's a few things we need to do. We want to enhance the player prefab to keep track of its score, and we want to enhance the GUI to display that. We want to enhance the GUI to display that score. And then of course get all the messaging in place so that all the clients know what's going on. Let's go ahead and start with the player script. We'll add a network variable for our score and a public parameter to access it. Now, of course, you could use a getter function for this, but personally I prefer to set it up as a parameter like this. When the player is spawned, we want to set up a listener on the player to know whenever it gets updated values, and all we need to do then is fire off an event to let the rest of the game know of our value change. Since we set it up as a network variable, netcode will handle keep the values in sync on the clients, and these events just let the rest of the client know when that individual client's value is actually updated. Again, I'm using Unity events here, but you can feel free to use your own event engine. We need a function to add our score when one of our dice roll, and we'll only let this happen on the server. The last thing we need to do is update our dice roll controller to listen for the die roll complete events from our dice, and when it's complete, update the score on the player. In our GUI, we'll add a couple of text mesh pro objects to display the score, and then we need a way to know which player goes with which UI element. Again, I'm doing a little bit of cheating here since we know we'll only have 2 players and the UI is not really central to this tutorial. In reality, you'd probably have prefabs set up to spawn as the users come in, but what we're going to do here is just listen for a player to connect. If they're the first one, we're going to set them up as player 1. Anyone else gets set up as player 2. Since it is possible that player 1 will spawn before the UI actually opens on the host, we will check first to see if any players already exist. We will get the UI registered to listen for the event that we set up on the player so that we know when its score changes, then we can go ahead and update the text. Now we can run the game again, open it up both our scene windows, and when you click roll in one, you can see the player's score updating on both clients, and that works for both ways. Alright, so hopefully that gives you a good idea on how to make a physics-based dice system that is synchronized on the network. I know I went through some of the networking pieces a little bit fast, so let me know if you do want me to go in depth more on any of that in the comments, and of course feel free to ask questions and I'll do my best to get to them. If this helped you at all, it'd be awesome if you'd hit that like button. That would of course help me a ton. I'm going to start putting out more tutorial content, so if you like this type of thing, please be sure to subscribe. Plus you'll be getting updates on all the games that I'm working on. Thanks and have a great day.